Q6612. When a helicopter experiences a translating tendency, it A. Moves in the direction of tail rotor thrust. B. Gains increased rotor efficiency as air over the rotor system reaches approximately 15 knots. C. Tends to dip slightly to the right as the helicopter approaches approximately 15 knots in a takeoff. The correct answer is A. When a helicopter experiences translating tendency, it moves in the direction of tail rotor thrust. Translating tendency refers to the lateral movement or drift of a helicopter in the direction of the tail rotor thrust during hover or low-speed flight. This tendency is a result of the unequal vertical forces acting on the helicopter due to the torque produced by the main rotor and the counteracting thrust generated by the tail rotor. As the main rotor generates torque, it tends to rotate the fuselage in the opposite direction of the rotor blade's rotation. To counteract this torque and maintain stability, the tail rotor produces thrust in the horizontal direction, perpendicular to the longitudinal axis of the helicopter. The horizontal thrust from the tail rotor creates an imbalance of forces, causing the helicopter to move laterally or drift in the direction of the tail rotor thrust. This lateral movement is known as translating tendency. Therefore, when a helicopter experiences translating tendency, it moves in the direction of tail rotor thrust. This phenomenon is a characteristic of helicopter flight and must be considered by the pilot when maneuvering and maintaining control during hover or low-speed operations. Hence, the correct answer is when a helicopter experiences translating tendency, it moves in the direction of tail rotor thrust. 6613-1. Most helicopters tend to drift to the right when hovering. What is done to counteract this? A. The mast is rigged slightly to the left. B. The direction of tail rotor thrust can be changed by using anti-torque pedals. C. The cyclic pitch system is rigged forward, and along with gyroscopic precession, this tendency is corrected. The correct answer is A. To counteract the tendency of most helicopters to drift to the right when hovering, the mast is rigged slightly to the left. The drifting tendency during hover is primarily caused by the torque effect of the main rotor. As the main rotor spins in one direction, it generates an equal and opposite torque that tries to rotate the helicopter in the opposite direction. This torque effect can cause the helicopter to drift laterally. To counteract this drifting tendency, adjustments can be made to the helicopter's configuration. One common method is to rig the mast slightly to the left. By offsetting the mast from its vertical position, a small amount of leftward tilt is introduced. This leftward tilt compensates for the rightward drifting tendency, helping to maintain a more stable hover. By rigging the mast slightly to the left, the helicopter structure is adjusted to counteract the torque effect and minimize the drift. This adjustment is typically done during the helicopter's initial setup or maintenance process to achieve better stability during hovering operations. Therefore, the mast is rigged slightly to the left to counteract the drifting tendency of most helicopters during hovering. 6613-2. Transverse flow effect is caused by A. Increased downwash velocity of air flowing over the rear portion of the rotor disc. B. Disturbed flow of air due to gyroscopic precession. C. Air flowing through the rotor system opposite the direction of forward flight. The correct answer is A. Transverse flow effect in helicopters is caused by the increased downwash velocity of air flowing over the rear portion of the rotor disc. During hover or low-speed flight, the rotor blades generate a downward flow of air, known as downwash, as they rotate. As the helicopter moves forward, the relative wind encountered by the advancing blade is higher than that encountered by the retreating blade. This difference in relative wind velocity causes a variation in lift between the advancing and retreating blades, known as dissymmetry of lift. The dissymmetry of lift results in a higher lift on the advancing blade and a lower lift on the retreating blade. This imbalance creates an uneven distribution of the downwash over the rotor disc. The downwash over the rear portion of the rotor disc, where the retreating blade operates, is relatively slower compared to the downwash over the front portion of the rotor disc, where the advancing blade operates. This difference in downwash velocities leads to the transverse flow effect. The slower downwash over the rear portion of the rotor disc causes a reduction in lift and increased drag on the retreating blade. Conversely, the faster downwash over the front portion of the rotor disc increases lift and decreases drag on the advancing blade. As a result, the transverse flow effect causes an uneven distribution of lift and drag across the rotor disc during low-speed flight, particularly in hover or during the transition to forward flight. Pilots need to be aware of this effect and compensate for it through proper control inputs to maintain balanced and controlled flight. Transverse flow effect is caused by the increased downwash velocity of air flowing over the rear portion of the rotor disc. 6613-3. Effective translational lift is that point during helicopter flight when a. hovering flight may be maintained. b. additional lift is obtained from increased airflow through the rotor disc. c. the increased ground speed provides additional performance required to transition from a hover. The correct answer is B. Effective translational lift in helicopter flight refers to the point where additional lift is obtained from increased airflow through the rotor disc. During hover or low-speed flight, the rotor disc experiences the effects of induced flow, vortex ring state, and other aerodynamic phenomena that limit its performance. However, as the helicopter begins to move forward and reaches a certain forward speed, it enters effective translational lift. At this point, the helicopter starts to benefit from the increased airflow through the rotor disc. The forward movement of the helicopter results in a more uniform inflow of air across the rotor disc, reducing the effects of vortex ring state and improving the overall aerodynamic efficiency. The increased airflow through the rotor disc leads to several advantages. First, it allows the rotor blades to operate in a less turbulent and more effective airflow, resulting in increased lift production. Second, it reduces the power required to sustain flight, as the rotor system operates more efficiently. Effective translational lift is typically experienced when the helicopter reaches a forward speed of approximately 16 to 24 knots, although the exact speed may vary depending on the specific helicopter design. Effective translational lift is that point during helicopter flight when additional lift is obtained from increased airflow through the rotor disc. 6613-4. The vibration that you notice in a helicopter when entering translational lift is a result of a condition called A. Advancing blade compressibility, B. Transverse flow effect, C. Dissymmetry of lift. The correct answer is B. The vibration that is often noticed in a helicopter when entering translational lift is a result of a condition called transverse flow effect. Transverse flow effect refers to the uneven distribution of lift and induced flow across the rotor disc during low-speed or hover flight. As the helicopter begins to move forward and enters effective translational lift, the relative wind direction changes, causing the airflow over the rotor disc to become more uniform. However, during this transition, there is a brief period where the airflow near the advancing blade is still predominantly in the hover or low-speed configuration, while the airflow near the retreating blade starts to resemble the higher-speed forward flight configuration. This creates a temporary imbalance in lift and induced flow between the two sides of the rotor disc. The transverse flow effect manifests as a lateral vibration or shaking sensation in the helicopter. This vibration is caused by the variation in lift and the resulting uneven loading on the rotor blades as they pass through different airflow conditions. The vibration that you notice in a helicopter when entering translational lift is a result of a condition called transverse flow effect.